In its simplest form, casting consists of creating a pattern or model of the finished product in order to form a mold. The passageways, known as runner bars and sprues, through which the molten metal enters the mold, are also incorporated into the pattern. To form the internal passages, cores of bonded sand are set into the mold cavity, often being held in place by small metal pegs known as chaplets. The two halves of the mold are then placed together, and the molten metal poured. Finally, once the metal has solidified, the casting is removed and cleaned, ready for machining. Always mindful of society's ever-changing needs, casting has developed in tune with the demands of its customers. The result is its evolution into 5 major processes, the basis of today's foundry industry. The oldest of the 5 is investment or lost wax casting, examples of which have been found in China, dating back nearly 4,000 years, where it was used predominantly for decorated vessels and jewelry. The process starts with the production of a wax model or pattern, which is coated in a refractory material and baked to form a hard shell. The wax is then melted out and the metal poured. This method produces fine detail and accurate dimensions with very little finishing required, making it ideal for many of today's complex engineering components. By far the most widely used of the 5 processes is sand casting. Here the mold is formed using sand mixed with a binder, which can be anything from simple clay to synthetic resins. Its use covers a wide range of alloys and is adaptable to castings of varying types and sizes. Shell molding, developed for the cost-effective production of small, accurate castings, uses sands bonded with a thermoplastic resin to form thin-walled, hard shell molds that are assembled to create the mold cavity. Unlike any of the other processes, die casting uses permanent molds made from gray cast iron. Limited to relatively small, thin-walled castings in ferrous and non-ferrous alloys, this process has become the dominant method of producing castings in aluminum, the molten metal being introduced simply by gravity pouring or under pressure. Another process that uses permanent dies is centrifugal or spin casting. This method is used for the manufacture of pipes and tubes in various alloys, such as gray or ductile iron and stainless steel. Here, a tubular mold is spun at between 600 and 1,000 revolutions per minute. The molten metal is introduced and spread evenly on the mold surface by means of centrifugal force. By this method, tubes and pipes can be produced in lengths varying from between 3 to 7 feet to up to 26 feet, and with diameters ranging from 4 inches to over 13 feet. With these forming methods, plus the varying levels of technology, from hand molding to self-contained, fully automated molding and pouring lines, there is a casting method to suit the needs of all.